we take a look at this function and we have to differentiate it, you can see that there's two functions multiplied by each other, which means that we have to apply the product rule. So if we remember the formula, your dy by dx is going to be, and we name this one u and this one v. So you have u times dv over dx plus v times du over dx. So u will be e to the power minus 3x, and dv by dx will be the differentiation of this, which is just cos x, plus your v is now sine x, and your du by dx is the differentiation of this, but this is also a function within a function, so you have to apply the chain rule, and if you do that, you get minus 3 e to the power minus 3x. And then you can just simplify this by taking your e to the power minus 3x out, and then you have cos x minus 3 sine x. And that's your answer. So when you have two functions divided by each other, we know we have to apply the quotient rule, and here is just the general formula. But let's try and work out the equation. So here we are going to name this one as v and this one as u, and then your dy by dx is going to be this over v squared, so it's just x squared plus 1 whole thing squared. Now if we need to get the differentiation of your u, you can see that this is a function within a function, so again we have to apply the chain rule, and I will show you how to do that. So if y equals x squared minus 1 whole thing squared, you can rewrite this as y equals u squared, and y equals u squared, and u equals x squared minus 1, and then you differentiate it separately, so dy by du, which is 2u, and du by dx, which is 2x, and then you get your dy by dx, which is basically 2u times 2x, and then that's 2 into x squared minus 1, because your u is x squared minus 1, times 2x, which is 4x x squared minus 1. So that is your differentiation of u. And then you plug it back into the equation, so you have 4x into x squared minus 1 times v, which is your denominator, so x squared plus 1 minus, I'm just going to erase this, minus the differentiation of the denominator, which becomes 2x times u, which is x squared minus 1 whole thing squared. And now we can just simplify this, so we can write this as 2x times, and the whole thing, don't forget the denominator, and then you just simplify this further. And here you can just do the 2x squared minus x squared, which just becomes x squared, and then your 2 plus 1 becomes 3. And that's your final answer. To find the minimums and maximum and inflection points of this function, what we first need to do is differentiate it. So our dy by dx is going to be 3 times 24 x to the power 2 plus 2 times 18 x, which is 72 x squared plus 36x. And then to find the x coordinates for the minimum and maximum, we have to equate this to 0. So we have 0 equals 72 x squared plus 36x, and then we have And then we know that x is going to be equal to 0, or x is equal to negative 36 over 72, which is basically negative half. But now to find that which of these x coordinates is actually the minimum and the maximum, we have to find the second derivative, and we do that by differentiating this function. So our d squared y over dx squared is going to be 2 times 72x plus 36, which is 144x plus 36. And now what we do is we substitute x into this function and see whether it's going to be positive or negative, and depending on that we know if it's minimum or maximum. So I'm going to do it here. So when x equals 0, our second derivative times 0 plus 36 is going to be positive, which means that at x equals 0 it's a minimum. And when x equals negative half, 144 times negative half plus 36 is going to be negative. So then we know that this is our maximum. But to find the actual coordinates, we need our y values as well. And so what we do is we substitute x into our original equation to find y. So when x equals 0, we know that y is going to equal 0. So our point for the minimum is just going to be 0, 0. But for our maximum, I'm just going to erase this. When x equals negative half, then y is going to equal 24 times negative half cubed plus 18 into negative half squared, which is 7.5. So our maximum is going to be at negative half 7.5 for y. And that's how you find the maximum and minimum. But now to find our inflection point, what we have to do is actually equate our second derivative to 0, if you can remember from the video. So I'm going to erase this again. And then we find our x coordinate. So we have 144x plus 36 equals 0. So x equals 36 over 144 negative, which equals negative 1 over 4. And that's our x coordinate. And again, to find our y coordinate, we plug this back into our original equation. So y equals 24 times negative plus 18, which gives us 3 over 4. So point of inflection is at negative 1 over 4, and those are the coordinates.